Hello everybody and welcome to the session in which we're going to see the statistics topic, tree diagrams. A tree diagram is a graph useful for organizing and analyzing business decisions involving several stages. Each segment in a tree is one stage of the problem. The branches of a tree diagram are weighted by probabilities. Now, we have this one example in which we see this contingency table showing the location and years of service of 80 bank branches in the UAE. From this table, we'll construct a tree diagram showing the joint probabilities for each decision. So now, as we can see here, we have the tree diagram will be based on the years of service of a branch, whether it is less than 3 years of service, and we're calling this A1, 3 to 5 years of service, and we're calling this A2, or more than 5 years of service of a particular branch in the UAE, and we're calling this A3. Now, we'll also have the location. If the branch is located in Abu Dhabi, and we're calling that event B1, Dubai, B2, Sharjah, B3, Khaybar, B4. Now, for a tree diagram, we can make a tree diagram either starting with the years of service, which is 3 different possibilities, or by the location, which we have 4 different possibilities here. Typically, it's easier if you start a tree diagram with the least number of possibilities. So it's either we have a choice between 3 here and 4 here. So we will start with the years of service. Now, typically, you will have the same answers, the same numbers, the same results, whether you start with the years of service or the location. It's just a little bit easier if you start with the one that's smaller. Okay, so to make a tree, we start with the root. Okay, and we said we have 3 different possibilities. Whether the company has had the branch working for less than 3 years, 3 to 5, more than 5. So we're going to call this A1, A2, A3. Okay, so we're only looking at the years of service here right now. Okay, so now let me erase a little bit here. Okay, so now from the branches that have less than 3 years of service, we have a total of 34 branches. How many total branches are for all the branches? 80. So we have that the probabilities are in the branches. So we have 34 branches out of 80 that have been in service for less than 3 years. Okay, the next one, 3 to 5 years. We have 24 out of 80. Okay, so 24 branches out of 80. How about A3? For A3, we have a total of 22 branches out of 80. 22 branches out of 80. Okay, so if I were to count them all together, you have 34 plus 24 plus 22. That means that you have a total of 80 branches divided by 80. 1. You have all the branches here. You have all the possible outcomes, which means that your list is collectively exhaustive. You have all your possibilities. Okay, let me see. All right, so we have now the service. Let's go and check out the rest of the information here. Let's look at the location. We have companies or branches located in Abu Dhabi, and we're calling this B1, Dubai B2, Sharjah B3, Ras Al Khaimah B4. So for each year of service selection, I have 4 possibilities. Okay, so I have from A1, 1, 2, 3, 4. Then we have B1, B2, B3, B4. Okay, same from here. I'll change the color to make it a little bit easier for everybody. Myself included 1, 2, 3, 4. So B1, B2, B3, B4. And you know what? That A3, I'm going to put it a little bit lower. So just same thing. I'm just going to get more space here. Okay. B1, B2, B3, B4. Okay, so let's get the probabilities for each of these branches. What am I talking about? I'm talking about here. The branches of a tree are weighted with the probabilities. So that's what we're doing right now. Okay, so for the probability here, how many branches that have been in this working, remember A1 is less than 3 years, are located in Abu Dhabi. Okay, so what are we talking about? Let's go check it out. So I want A1, B1, basically. Okay. A1, B1. We're talking about this ones. 8 branches are in Abu Dhabi that have been in service for less than 3 years. So this is 8 branches out of the 34. So from now on, let me highlight here. We are only talking about this. The people or the branches, I'm sorry, that are with less than 3 years of service. So we're gonna only talk about this one row. Okay, so let's get it done. This is, we said 8 out of 34. So this is 8 branches out of 34. All right, so now let's go and look at B. Oops. B2 is 12 divided by 34. B3 is 9 divided by 34. And B4 is 5 divided by 34. Now, if you add all the branches together, you have 34 plus 12 plus 9 plus 5. That will be equal to, if you add all of this here, you will have 34 divided by 34. Again, equals to 1. So all of your branches together for each of the events should equal to 1 because your list is collectively exhaustive. What that means is if you are given a tree and you don't have a section, you can calculate it, right? You can use the complement rule to figure out what is needed. Yes? You can do, to get that number here, you can do 1 minus the rest of the stuff, the rest of the branches. 8 34 plus 9 34s plus 5 divided by 34. And therefore you will get the one that is missing. Okay. All right. So, which in this case we said is 12. 12 divided by 34. Okay. Let me erase everything here. Perfect. And let's talk about the next set of probabilities. Let's talk about A2. Okay, what is A2? We're talking about the branches that have been in service for 3 to 5 years. Now we're going to see how many are in Abu Dhabi, Dubai, Sharjah, and Ras Al Khaimah out of a total of 24. Okay, so A1 B1, A2, B1 is 4 of them. So this is 4 out of 24. So I'm going to change my color here. This is 4 out of 24. Yeah, you see, we're going to use now divided by 24, and we're going to use this divided by, as we use divided by 34, and the one above. Okay. The next one is 10. This is 10 divided by 24. The next one is 6. 6 divided by 24. And the last one is 4. 4 divided by 24. So, again, if you add 4 plus 10, that's 14. Plus 6, that's 20. Plus 4 is 24. So 24 divided by 24 equals to 1. Our last section here is to do the probabilities for A3. Only the ones for A3, and we have a total of 22 of them. We'll go check it out. Okay, so we are talking about A3 information only. So now we're talking about A3 only about this right here. We have a total of 22 of them, and we'll see how much for each of the locations. So more than 5 years, and in Abu Dhabi is 2, then 11, 7, and 12 out of 22. So each of those branches we're going to divide by 22. So 2, 11, 7, and 2. Okay. So this is 2 divided by 22. Next one is 11 out of 22. This. All right. Then 7 out of 22. And, my goodness, sorry. Here we go. And the last one is 2. Again, 2 divided by 22. Okay, let me have a little bit better handwriting. 7. It was 2, 11, and 7. You see, I've done it. This one was here, was 11. Let me just, it was 2, 11, and 7. Here we go. 2, 11, this is 7. Okay. All right. So now, if I add 2 plus 11, that's 13. Plus 7, that's 20. Plus 2 is 22. So we have then 22 divided by 22, which is equal to 1. Okay. Our last step is to calculate the joint probabilities. So how do we do that? I'm going to put it here. Calculated the joint probabilities. Okay, to do that, we multiply across. For example, the probability of an event, remember this is years of service, A1 means less than 3 years of service. Okay, A2 meant 3 to 5 years of service, 3 to 5 years of service, and A3 meant, I keep showing you the answer, more than 5 years. Don't worry, you will see it. More than 5 years. Okay, and then this was a location. It was Abu Dhabi. It was Dubai. It was Sharjah. And it was Ras Al Khaimah. Okay, so the probability that a branch is located in, less than 3 years of service, and that is located in Abu Dhabi, okay, is equal to, let me make this little arrow a little bit bigger, is equal to, you have 34 divided by 80 for less than 3 years of service, and then you had 8 branches out of 34 that are in Abu Dhabi from that. What am I doing? I am looking at, let me see. Will this look okay? No, it will not. close. I'm getting close. Okay. I want highlighter and I want it in yellow. Here we go. I'm talking about this number and I'm multiplying it by this number to get this here. Okay, so what is happening here? We have that this 34 and this 34 cancel each other out, and therefore you have 8 divided by 80. Okay, let's look at the next one. Gonna look at the probability of a branch being in service for less than 3 years and that is located in Dubai. Okay, so how do we do that? We multiply again 34 divided by 80. Yes, times how many are in Dubai? 12 divided by 34. Okay, so again, just like in the one above, a way to check whether you're doing this right or not is that you should have some of this canceling out, which means the 34 in the denominator and numerator goes away, and you have 12 divided by 80. All right, so what has happened? I have multiplied this number here by this number here to get this number. Okay. All right. Let's do the next one. Okay, I'm going to look at this and for B3 in this case. So the probability that a branch has been in service for less than 3 years and that is located in Sharjah. Okay, so that's equal to, let me see, 34 divided by 80 times, and we have 9 divided by 34. Okay, the 34s go away, and that means 9 divided by 80. Okay, where did I get this from? This 34 and that 34 goes away. So 9 divided by 80. Okay, ladies and gentlemen, if any of you is listening here. The last one, we'll do the probability that the location is working less than 3 years of service and is located in Ras Al Khaimah. Okay, so that is equal to 34 divided by 80 times 5 divided by 34. Okay, so the 34s cancel each other out just like before. And that is equal to then 5 divided by 80. Okay, and again, I have multiplied across from this number here to this number here to get this. Okay. Let's do the next set that is talking about the branches being in service for 3 to 5 years by each location. Okay, so let's figure it out. Okay, for this one, you have the probability of A2 and B1. Okay, which is 24 divided by 80 times 4 divided by 24. Okay, 24s go away, cancel each other out, which means 4 divided by 80. Okay. Next one is 24 divided by 80 times 10 divided by 24. Again, 24 cancel each other out, which means 10 divided by 80. All right. Don't worry. You'll get the quicker, the more practice you have. The next one is 24 divided by 80 times 6 divided by 24. 24s cancel each other out, and that is 6 divided by 80. Last one of the set is 24 divided by 80 times 4 divided by 24. 24s cancel each other out. 4 divided by 80. Okay. Last set. So in this last set, we're talking about the branches that have been in operation for more than 5 years by each of the locations. So we'll start with, we're going to be multiplying each of these sections by 22 divided by 80, and we're going to do it for each of the branches. First being in Abu Dhabi. Okay, so that is 22 divided by 80 times 2 divided by 22. Okay, so this 22, they cancel each other out, and it's 2 divided by 80. All right, this one is 22 divided by 80 times 11 divided by 22. 22 cancel each other out, 11 divided by 80. Next one, let me change the color here. This is 22 divided by 80 times, second one is, I'm sorry, I'm on the third one. Let me highlight it because we have a lot of information now. So I'm looking at the third one. Yeah, it's this one right here. So 7 divided by 22. 7 divided by 22, which is 7 divided by 80. Our last one is 22 divided by 80 times 2 divided by 22, which means 2 divided by 80. All right, now, just like as we added all of the branches before, yes, if I add all of this, I will get equal to 1. Same with our joint probabilities. If we were to add all of these probabilities, that would also equal to 1. And again, if you have one of them taken out, yes, for example, let's say we, my highlighter, if this was not available for you, you could get it by doing 1 minus the rest of them, okay? So you can do the complement rule to figure out if any of the probabilities are not given to you, especially on the exam, right? And here I've showed it to you by mistake a couple of times earlier. This is what we're looking at with that one contingency table, converting it into a decision tree and the probabilities for each of the branches. Each branch has is weighted by probability. Yes. Each branch is weighted by probability, and when you add all of the probabilities in your branches, all of them together, when you add them, they're equal to 1. Okay, equal to 1. When it's equal to 1, any of your probabilities, once you add them together and they equal to 1, that is known as collectively exhaustive. Thank you so much.